last week, we covered quite a bit. We learned how to place a request for SAS Studio. We were able to list highlights in the history of SAS. We were able to access SAS Studio, the free version of SAS, and we're comfortable navigating the SAS Studio through a series of videos, and as well as, live discussions or commentary from yours truly. And then we transferred an Excel file, which is exactly the same way you will transfer a comma-separated values file, or CSV for short, into SAS. So today our attention will focus a bit on being able to label or declare variables and data sets using SAS naming conventions, and be able to execute a variety of SAS programs and assign libraries. A library is the equivalent of a folder on your Windows or Mac laptop, but in SAS environments, they are called libraries. So I'm going to skip over all these lectures slides as we've already covered them in last week. And then I believe our last slide was this. I finished going through what each of these specificities were, and now I want us to begin today's lecture having a bigger picture in mind. So the bigger picture in data science is that invariably you have your data most likely sitting outside the programming environment you want to program in, and in this case it is SAS, and you are trying to import it inside this box that you have. And within the box are tools. If you think of a carpenter's toolbox, then maybe there will be hammer, there will be the saw, hand saw, or some other type of tools. And so in SAS and most other, this cuts across programming languages. There are usually visualization tools, there are analysis tools, there are transformation tools. But after you finish experimenting all of that, the goal is to be able to interpret whatever it is you've explored and communicate that to the right audience. It could be your boss, it could be your client, and it could be, if you're a student, your professor. And if you are attending conferences, then maybe conference attendees. I took this slide from a lecture by William Ampe, and I'm giving credit to his slide. I also found a nice pictorial representation of what is very specific inside the SAS toolbox, and this is credited to Anna Yakovlev's lecture on Introductory to SAS. So the big picture number 2 is within SAS, you are here signifying where your raw data has to be analyzed. So last week we pulled in the Global Superstore 2016 Excel file data. And so for this purposes, that's our raw data. And then what we bring into, remember we said we had 2 types of steps in SAS, data step and procedure or proc step. And so you bring in the data, and you have your data statements and other SAS statements packaged within a data step. And now you convert it to a SAS data set, and then it's ready for you to apply procedures on top of whatever you've brought in through your data steps, called proc steps or procedure steps. And then you have the results of your analysis. And most likely, sometimes you place the analysis in a finished report. If you are in a corporate setting, it could be a quarterly report, monthly report, weekly report, depending on the cadence that the people that have authority over you are demanding from you. So typically there is, the student learns SAS or programming languages in a university setting, and you are typically your professor, if you're a student, gives you a list of questions in an assignment that you must answer. And so I went on Tableau, which will be one of the follow-up courses in this series by myself. Tableau's first lesson will be on September 30th. I haven't prepared the lecture slides, but I'm hoping there wouldn't be any bumps towards that class. And so I went on the Tableau community, and Global Superstore is also available in Tableau, probably more popular by Tableau users. And I'm going to put that link to the sample questions. Somebody on that community most likely was given an assignment and was asked these questions. And so I tried to pull those questions. Even though there are 4 questions here, I'm really going to demonstrate the first question, but the 2, 3, 4 can be your assignments going forward. And I will try to, answer them if you reach out to me. I'm trying to use this moment to show you exactly what happens when you are faced with questions or problems. The main distinguishing feature or factor between working as a student in an academic environment is that your professor typically gives you the question that you must solve. Not so much in the corporate world, if any at all. Once you get a job and people believe you can do SAS, you would have to come up with the questions in conjunction with your client or supervisor or team members if you're a team lead. And so nobody gives you the questions. You have to figure that out. So someone has posted these sets of questions and is saying, can anyone please help me in solving the below sample questions? It's interesting. Go read the thread. People are saying, well, you have to do it and we can help you if you are stuck, but we just cannot solve the problem for you just like that. And so that's a lesson when you are posting comments on a SAS community, or in this case, a Tableau community. Make sure you've done your work, and then you can communicate what you did, where you are stuck at, and people can help you. But do not post it like this user did. And so with a question like this, it says, using orders in the Global Superstore data set, I'm adding the data set for emphasis, which subcategory has standard deviation for sales and profit 1 point more than the mean of sales and profit? So what I did was I just went to Google and did hold on, I need to bring I have 2 screens, so I Googled this. Proc means SAS class example. Class example because the class is how I know from this by experience that the class is how you group the proc means. But I imagine even if you don't have that self-awareness to use class and you do SAS, proc means SAS example, then this is going to pull up something like this. And then you're going to get something like this. I like the listen data because I've already been there prior to class. They tell you some examples to use. At some point later, I'll talk a little bit about what proc means does. But suffice to say right now, proc means is how you get means and averages and a bunch of other statistics in SAS. So I come here, they've given a syntax of what proc means is. And then what I'm going to do is I am going to go into my SAS environment. And I'm going to copy that, exactly that. Remember, when you first relaunch your SAS environment, you will need to create your library, and I will get to that. And in this case, the library that I chose was this library. Okay, let me just redo it here instead of trying to find that file. So how you create a new library is using a libname statement. And I'm going to call it WWC, Women Who Code for short, 2023. And I'm going to put a path to this folder into this location. And so I'm trying to find the path length. Okay, I have the user-defined library. And so this is how you create a folder. You use the keyword libname. You give it a name. When I was in grad school, they said the max is 8 characters, which is why I kept with it. It's possible that they've extended it these days, but I stick to the 8 character limits when I'm giving library names. And then this is the path. Remember, the U identifier will be unique to yours. And then the SAS.v94 is equivalent to this folder. And so when you run this, as in highlighting it and hitting the run guy, it gives you a location, right? No errors because the arrow didn't show anything. No notes. And then SAS tells you that it's successfully, is giving another note, probably because I ran it twice and I wasn't seeing it, but it's saying your lib reference or libref was successfully assigned. And so that's something that I quickly wanted to show before running the program. Okay, so now we have the path, right? Oh no. Let's forget the path because I've already run it as evidenced in the other. Right. Let me clean this up. So how you look at the contents of your data set. Remember, we are trying to answer this question using the orders in Global Superstore, which is one of 2 tabs in the Superstore dataset. Which subcategory has standard deviation for sales and profit? 1 point more than the mean of sales and profit. And so you come here, you've already Googled and you went to lesson data. You've copied this syntax because lesson data has told you that's the syntax. You come here and it's time to modify. So you go to WWC_2023.orders. As I said last week, that means I'm placing the orders data set inside the WWC_2023 folder or library. I don't think I need the by variables, but if you want to know more about where this lesson data set resides, you just read more and it will tell you what each of these means. You know, it's saying, there's some ads here. It's saying, explaining what each of these means. Now, remember, you always have a backup in SAS documentation itself. And later today, I will demonstrate some of those things to you. So I've modified. One thing I want to say is when you run this, content is going to list the whole data dictionary, which lists the variables or columns. And then it also lists the name of the variables, the type of that variable, and on and on. Notice that in this case, the subcategory has a hyphen. And so if I just copied that and I run it without surrounding it with quotation marks and an N, this is just the fixed way SAS wants you to communicate to it if the subcategory is not like, you know, a list of characters without hyphen or space. So if I were to run this proc means, it's going to say variable sub was not found because it's breaking the subcategory and the sub from the category. And so you have to surround it with this quote here and then add the letter N to it. And then now when you run it, you're not going to have any problems. And so I'm trying to make it zoom in. It is Control+, and it's now giving me the subcategories, the number of observations, that's NOBS, the columns, sales and profits. How did it know? It knew to produce sales and profit because of this var statement. And then it's now giving you additional stuff like the label. Sometimes column names in the data sets have different labels. For instance, you can say a variable is age in the actual file, but maybe in the label, you want to say ages of, you know, citizens of the US, just to be more descriptive. But if you don't force it with a more tighter descriptive label, then SAS will just use the name of the variable as the default label. And that's why it's repeated information in this case. The N is the number of rows or observations. In SAS, rows are called observations. Then there's the mean, which is another way of saying the average. There's standard deviation. There's the minimum and there's the maximum. This is amazing. Look at the number of output we are just getting by running proc means, and it's breaking it down by the category. And so the question is asking, when I look at the mean and I look at the standard deviation, which category is incremental by 1 point? I'm going to zoom up and then we are going to look at the columns of mean, standard deviation. So let's look at that. We see that we will look at sales first. We have 243, 327. It's not incremental by 1 point. 580 to 798, not incremental by 1 point. 76 to 82, not incremental by 1 point. 75 to 88, again, that doesn't qualify. It doesn't qualify for the next one, 608, 602, 437, 535, 679, 821. But when we get to envelopes, you know, the envelopes line, we now see that for the sales, we have 70.89, and then we have 70. And so when you do the roundup, you are getting the 1 point incremental change. And so we've identified that for envelopes. So now that we have identified it for envelopes, we are going to skip to the top and start now with profits to identify the 1 incremental change. So 81 to 42 to 126 doesn't qualify. 81, 303 doesn't qualify. 11 to 32 doesn't qualify. 11, 154 doesn't qualify. 67, 40 doesn't qualify. 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 Also doesn't qualify. And it didn't qualify. So let's go back to the question. Yeah, so I believe we were able to identify it for sales, but for some reason, I'm not getting it for the profit. But that's how it's good we got it for the sales. And it might not be the best to do it visually like I'm doing it. You know, maybe you download the data set and just take the differences. But that's how you approach something like this and use the combination Google to get to the destination you would like to go. So here's the output that I saw before. And you will continue. So I did some research. I've already shared that in the academic environment, you are giving questions and you are focused on finding the answers. But that doesn't happen in the corporate world when you get a job. There's a concept called exploratory data analysis, which you learn from academia, but you really put your foot to the pedal of the gas once you are solving real life problems. So let's watch this video from Wesleyan University talking about, what exploratory data analysis is. And let me make sure I put the lesson information in the chat before we continue. This is how you get to the lesson example and how you get to the Wesleyan video. And so it's a course on Coursera. So I think it's loading. Let me see if I can find one that has already loaded. Okay, it did this quickly.
Raw data consists of long lists of numbers and labels that don't seem to be very informative. Raw data lacks context. Exploratory.
Can you guys hear the sound?
Yes, yeah.
Yeah, the sound is coming through, right?
Yep.
Okay, great. Thank you for
can.
coming.
Data analysis is what you use to make sense of the data. You do this by converting data from its raw form to a form that makes sense, that has context, that tells the story you want to tell. Basically, exploratory data analysis consists of organizing and summarizing raw data, looking for important features and patterns in the data, looking for any striking deviations from those patterns, and interpreting your findings in the context of the problem or research question. We begin exploratory data analysis by looking at one variable at a time, also called univariate analysis. In order to convert raw data into useful information, we need to summarize and then examine the distribution of any variables of interest. By distribution of a variable, we mean what values the variable takes and how often the variable takes those values.
If we were studying a small number of observations, we could do this with a pencil and paper, a calculator, or even in our heads. The data sets you're working with often have thousands of observations. Working with such large samples is only achievable if we use statistical software. These software programs require the use of syntax or formal code to retrieve, analyze, and manipulate data. Learning to write code, learning the proper use of syntax, can really expand your capacity for engaging in statistical applications and is a central skill you'll learn in this course. This skill will also greatly expand your capacity for engaging in deeper levels of quantitative reasoning about data.
For this course, you'll be using SAS Studio. SAS is a very powerful statistical software package. Looking at all the windows, menus, and features, though, can be rather daunting. So it's important for you to realize that this course will introduce you to the basics of SAS. You will learn what you need to know to get started asking and answering interesting questions about data.
In the beginning, it may feel like you're learning another language. Basically, you are. As you work through your project, you should begin to feel more comfortable implementing the various decisions you'll be making about the data. When you need help, seek it from your course moderator, professor, your peers, or from course discussions.
No.
Now you need to register for SAS on demand.
So I hope that was helpful in letting you know a little bit about what exploratory data analysis is. Another thing that I thought would be helpful was try to visualize the options you have as you perform exploratory data analysis. And again, there is a cheat sheet by an organization called Data Camp that does a good job of all the visualizations that you can possibly do while all the visualizations you can possibly do while you try to bring meaning into the data set that you are looking at. So we are going to go around and we are going to read the middle text. I'm just going to use since we are not a whole lot. And so when it comes to your 10, or let me volunteer one person so it's quicker and it's less. Shrina, I'm going to volunteer you.
Okay, yep.
Please read what a line chart, multi-line chart, area chart, stacked area chart, and spline is. And you're just focusing on the middle.
Okay, right. Line chart, the most straightforward way to capture how a numeric variable is changing over time. Multiple line chart captures multiple numeric variables over time. It can include multiple axes, allowing comparison of different units and scale ranges. Area chart shows how a numeric value progresses by shading the area between the line and the x-axis. Stacked area chart, most commonly used variation of area charts. The best use is to track the breakdown of a numeric value by subgroups. How do I pronounce that?
Spline.
Spline. Spline chart. Smoothened version of a line chart. It differs in that data point are connected with smooth curves to account for missing values as opposed to straight lines.
Thank you very much. And so this grouping is whenever you want to capture a trend. And the trend is, something that, as you can tell, it varies over a certain interval or time. We're going to go to the next group, and I'm going to volunteer one person. Yawopo, am I saying it? Maybe it's Yao, but I see your username as Yawopo. If you can read the headings and the middle text.
All right, great.
Thank you, Sharina.
So for the bar chart, it is one of the easiest charts to read, which helps in quick comparison of categorical data. One axis contains categories and the other axis represents values. Column chart, also known as a vertical bar chart, where the categories are placed on the x-axis. These are preferred over bar charts for short labels, date ranges, or negatives in values. Scatter plot. This is the most commonly used chart when observing the relationship between two variables. It is especially useful for quickly surfacing potential correlations between data points. Connected scatter plot, a hybrid between a scatter plot and a line plot. The scatter dots are connected with the line. Bubble chart, often used to visualize data points with 3 dimensions, namely visualized on the x-axis, y-axis, and with the size of the bubble. It tries to show relations between data points using location and size. The last one is the word cloud chart, a convenient visualization for visualizing the most prevalent words that appear in a text.
Thank you so much, Yaopo. We're going to group. These are part to whole charts. And I actually like the reading so far, but let me see. David Mensah, can you read the headings and the middle text? Oh, and I forgot to give the credits to these charts. It's Richie Cotton is at the bottom with data camp. David, can you read? I think you probably on mute. If not, then Sharina and Yaopo, I will call on you again just to keep this moving quickly. Okay, Sharina, I don't know what's happening today, so please read again.
Okay, pie chart. One of the most common ways to show part to whole data. It is also commonly used with percentages. Donut pie chart. The donut pie chart is a variant of the pie chart, the difference being it has a hole in the center for readability. Heat maps. Heat maps are two-dimensional charts that use color shading to represent data trends. Stacked column chart. Best to compare subcategories within categorical data. Can also be used to compare percentages. Tree map charts. 2D rectangles whose size is proportional to the value being measured and can be used to display hierarchical structured data.
Thank you, Sharina. Yaopo, please come back again to read both pictures, the middle text.
Okay. Card. Cards are great for showing and tracking KPIs in dashboards or presentations. Table chart. Based to be used on small data sets, it displays tabular data in a table. Cloud chart. I hope I'm pronouncing that correct.
I think it's gauge. Gauge.
Gauge. Oh, sorry, gauge. This chart is often used in executive dashboard reports to show relevant KPIs. Histogram shows the distribution of a variable. It converts numerical data into bins as columns. The x-axis shows the range and the y-axis represents the frequency. Box plot shows the distribution of a variable using 5 key summary statistics: minimum, first quartile, median, third quartile, and maximum. Valin plot, the variation of the box plot. It also shows the food distribution of the data alongside summary statistics. Density plot visualizes the distribution by using smoothing to allow smoother distributions and better capture the distribution shape of the data.
Wonderful. And then I'll read the last one. Sankey chart, useful for representing flows in systems. This flow can be any measurable quantity. Chord charts, useful for presenting weighted relationships or flows between nodes. especially useful for highlighting the dominant important flows. Network charts, similar to a graph, it consists of nodes and interconnected edges. It illustrates how different items have relationships with each other. Now, while we've given a whole host of options, always remember that you need to connect with your client and, with your professor, or whoever has the authority in your relationship with them, to know if they will appreciate the type of chart you want to put forward. So don't just foist this on people. Just make sure there's a little bit of communication before you choose a chart. But I know that line charts, area charts, and bar charts, column charts, scatter plots, bubble, word cloud, pie charts is very common. Tree map and heat maps are also gaining popularity. Box plots is a favorite of statisticians and so forth. So that's the options you are going to think about. So I took time to explain the journey we are going on and not just get into the nitty-gritties so much, so that you'll be able to hopefully take it in bit by bit. We've already shown how to import an Excel sheet last week, and we use the proc contents to look at the data dictionary. Whenever you bring in data, you want to immediately do some quality checks, because you have your source data in Excel and you are importing it into another programming environment. And so immediately you need to conduct some checks, and I'll show some of the handful checks you typically have to do. We already went over how to create a user-defined library, so I'll quickly glance through that. Then we'll look at temporary versus permanent SAS data set, sort SAS data set, merge two data sets which are in SAS, SAS frequency distribution, SAS macro, subsetting data sets, if then else statements, and tags and utilities using a GUI, that is graphic user interface, is the abbreviation for GUI, to interact with the data and visualize the data. Let's watch this video. It's going to talk about the components of a fair SAS program.
In this video, I'm going to show how to run your very first SAS program based on the input file, the Global Superstore Orders 2016.xlsx file, or an Excel file. As noted, the green text are the comments, %verb _drop _table signals to SAS that this is the beginning of a SAS macro. This is an inbuilt SAS macro. Work.import is signaling to SAS that the super or the Global Superstore Orders Excel file, after running this macro, will store it in the work library, and the file name will be called import. File name is telling SAS where to find the Global Superstore dataset, and it's within the home environment, my URL, the SAS user v9.4, and then the Excel file, which is equivalent to saying go here and in this folder. So see, this is home, and then my SAS user number and then the SAS user.v94. The first procedure we encounter is proc import, and it also points to the location of the file. dbms equal to xlsx is telling the procedure that this is an Excel engine and is outputting to work.import. Get names is an option that says the header information should not be ignored even as you read in this file. And then there's the run statement, which closes all SAS procedures, and as later we will see, data steps. So for your information, SAS has two types of blocks of code. We are seeing the procedure step, but there's also another step called the data step. Then the second procedure, proc contents, is how SAS interacts with data and provides a data dictionary. And so notice in the first block, run is entirely by itself, but in the second block, run is on the same line as the codes. Either way is fine as long as you remember to put spaces to make it readable. Then we have the closing parenthesis of the SAS macro, %web_open_table. I would like to turn our attention to some of the menus above, particularly the code, log, results. So whenever you're running a SAS program, these three parts will be open. The code is where you put in your SAS program. The log gives you a list of your errors and warnings and notes. So right now there is nothing because I'm yet to write or execute or run this program. And then there's results, which has a table of contents. And then there's even some settings tab here, which I rarely touch, but it gives you good file information. Then there's split, and going back to code/results. I would like to highlight the running guide here. That's how you execute. So you have an option to just hit the running guide and everything under code will be run. Or what I typically do is to highlight a section of the code that I want run. So if I want to run the comment section, I will highlight and then I'll click on this running guide. If you want to save, this is the save button. If you want to save as, that's the next button. And if you want to maximize, this is how you do it, and then you can go back. Then there's log and code, so you can toggle between both and code. In the next video, I will show you how to run this SAS program and also look at the results and the log. Thank you for watching this video. Bye for now.
Okay, thank you
In this
for
video,
watching.
I'm going to show how
I want to quickly in this link that I've put in the chat. Yes, Yawopo, I can send you. I already sent the link in the general email, I think yesterday or earlier today. But if you email me, and I'll give my email at the end, I can send it to you directly. But I don't want more emails just for the links, because I will email it to the meetup group as a group email, which is easier for me. I wanted us to quickly touch base on naming conventions in SAS. You've noticed that I'm naming data sets names. What convention am I exactly using? And so naming conventions in SAS, according to O'Reilly, some of the frequently used functionalities in SAS where naming conventions need to be followed are variables. That is the column names in Excel. Familiar lingo, but in SAS is variables. Then data sets, formats or in formats. Formats display how the data should look in a column. For instance, if you have currency value and you want to show the dollar signs, maybe add 2 digits or decimal places, you use formats. In formats is what tells SAS what is in the data file when it's reading the file into SAS. And so that's the difference. And these are user created. They are arrays, labels, macro variables, library names, and file references. And you've seen a combination of that, but I just wanted to highlight that. Then these are the general rules for SAS names. Variable names can be up to 32 characters. So it means you can't say my file name or data set name is Afia Owusu-Forfie data set living in the United States, because you just want to be descriptive. You always have to cut it down and be mindful that you don't have more than 32 characters. You saw me when I used the lib name that I limited it to 8 characters. I thought maybe it has changed, but it does appear that it's the same convention since many years ago when I was in grad school. The good thing is SAS isn't case sensitive in some specification, unlike some other programming languages or other statistical packages. I know R and Python, well, I should say R because I saw that earlier today in another class, is very unforgiving. So if you are naming and you use capital N-A-M-E, and then in the next phase, you want to reference it and you use all capital letters, N-A-M-E, is not going to connect because they are different. But in SAS, I believe this sentence is validating that that's possible. It will recognize it. The name cannot start with a number. It needs to start with a letter or an underscore. And the second character can be a number or an underscore. So this means when you are naming, you can't start it with 1, 2, 3. But after you start with a letter, you can put numbers in the subsequent letters. And then no special characters are allowed except underscore. So I wanted to quickly mention that because it was in our learning objective. Let's look at how you run a SAS program. You've seen me do it, but
in this video, I'm going to show how to run your very first SAS program based on the input file, the Global Superstore Orders 2016.xlsx file or an Excel file. As noted, the green text are the comments, %verb underscore drop underscore table signals to SAS that this is the beginning of a SAS macro. This is an inbuilt SAS macro. Work.import is signaling to SAS that the super or the Global Superstore Orders Excel file, after running this macro, will store it in the work library, and the file name will be called import. File name is telling SAS where to find the Global Superstore dataset, and it's within the home environment, my URL, the SAS user v9.4, and then the Excel file, which is equivalent to saying, go here and in this folder. So see, this is home, and then my SAS user number, and then the SAS user.v94. The first procedure we encounter is proc import, and it also points to the location of the file. dbms equal to xlsx is telling the procedure that this is an Excel engine and is outputting to work.import. Get names is an option that says the header information should not be ignored even as you read in this file. And then there's the run statement, which closes all SAS procedures, and as later we will see, data steps. So for your...
Have I already run this video? Is that what it looks like? I think I wanted to run this instead. Sorry about that.
Having successfully explained each of the components, let's turn our attention to hitting the running guide and running the SAS program. In this case, because I've already reviewed the contents, I'm going to not highlight any section or use Control plus the letter A to highlight all and then hit the running guide. So now SAS is running the import procedure to bring the internal data sets, the Global Superstore Orders 2016 file, which we previously uploaded, and creating a copy of the Excel file as a SAS data set with an extension .sas7b dat. Notice that after it finishes running, the first thing we see are the results, and it's giving us some kind of information in this data table, which is pretty cool. We know the data set name, the member type being, I believe, the data step, the engine version 9 that is using, the date it was created, on September 9th at 1:27 a.m. More information that the average user need not know, but SAS really gives you the number of observations, which is interchangeable with the number of rows, which is 51290, 51,290 observations. And then variables are interchangeable with columns. So SAS is saying there are 24 columns. And then the length of the observation is 456. Their indexes are 0, etc., etc. Then it gives you some information about the engine, and most people do not need that section. And here we see how SAS has already run the import procedure, but now it's presenting the output of the proc content or the content procedure, and it has the variable. The position of the variable is signified by the ##. So this means category column or variable can be found in column 16 of our data set. Notice that the type column is CHAR or NUM throughout the data set, which is one of the reasons why I love SAS, because you have to only be concerned with 2 data types. Then there's the length of each variable set, there's format, there's informat, and then there's the label. And some of these things will become clear in our future lectures. Let's look at the log. And here we see there are no errors in our program. There are no warnings, but there are notes, 5 of them. And it's telling you notes like some variables were converted because the data type was not supported by the V9 engine. The import data sets had 51,290 observations or rows and 24 variables or columns. And the work import data set has been successfully created. So SAS is basically affirming your stuff and saying, hey, you may want to check this out. But as it typically goes, the errors, if you see an error, it will be red. You definitely have to fix your program. If you see a warning, you may have to fix your program. And most notes typically don't or aren't deal breakers. And so that's something you should know. And so in this video, we've learned about running our first SAS program based on the Global Superstore Orders 2016 Excel file. Bye for now.
So the third video is how to play with the data
In this
in the environment.
video, we will explore the Output Data tab, which is housing the data set that we just brought into the SAS environment. So just as we saw before when we explored the cars data set in the SAS help default library, now we see the same window panes being presented in this new data set that we just brought in. So here again, you get to the variables. When you select the variable, the property and value and label are shown in that pane. If you want more space, you can do maximize view, and the row ID is the first variable followed by order ID, and you can scroll from left to right and explore your data set, and looks like everything is looking okay. There are no weird stuff. And this is the top part of the program, 1 to 100. And then the last set of programming rows are from the 50,000, 51,000 between 51,201 through to 51,290. So that's how you explore your data set. And so you can always toggle back and display the code, or you can X out of the maximization. So notice that SAS has also generated additional procedure.
Yeah, that might be a little confusing, but because it's interactive, sometimes it self-produces some additional codes, and that was an example of that. So we are past the 1 hour mark, and so, but my schedule is very tight, and so I definitely want to complete it today. So I think we should take a 5-minute break here and then continue and power through this, okay? So 5-minute break, or maybe even 10 minutes, and I'll play some music for you guys as you relax. Does that sound like a plan? Okay, thumbs up from Poppy and Sharina. Thank you. Let me know if you hear the music in the chat. Okay, great. I'll grab some water and walk around a little bit myself.
Hello, Afia.
Yes.
Good evening. Can I speak?
Yeah, sure.
Nice meeting you. After a long
Likewise.
day. Sure. Even though I mixed part of your this thing, I think I'm so happy of your performance, and it's great.
Thank you.
And
Thank
you
you.
can also continue sending me emails. You have been very engaged, but it's still pressing, and I've now bounced back. Congratulations.
Thank you. Thank you so much. Thank you, David. Always good to have some reassurance. So the list of concepts that I listed earlier, remember this one, is what we are going to attempt to power through. But I'll put a hard stop at 5 p.m. because I don't want you to go beyond that. So brace yourselves. So when you are doing quality checks, what you want to do is that, what you want to assess is that what you had in your source file, in this case, it's an Excel file, but sometimes it can be in a notepad file. It can be in an ASCII, which is ASCII format. These days, people even have application programming interfaces that typically store data in JSON files, JSON. So I'm putting ASCII and JSON. There are so many variety. These days, there's social media, like Twitter can give you a whole dump of all the tweets that have happened concerning a set topics in the past, let's say 4 hours or 24 hours and stuff like that. But whenever you transfer the data, you want to make sure that what was in the source file is exactly the same as what you've brought in your programming environments. And so that's the point I'm trying to make here. You look at the screenshots on the left, the Excel, it has order ID, order date, and you can tell that in the screenshots on the SAS, even though the window is constrained, at least we are getting similar values for, but that's the idea. I don't think the screenshot is really doing a good job, but that's the point. So these are some of the example checks that I use. I go to the source file, I look at the top 5, then I go to the bottom, I look at the bottom 5, and then I compare it across the source and the data. And then that lets me know that I'm doing a good job. When your file is very big, maybe top 5, bottom 5 might not be what makes sense. Maybe it's top 1,000 or bottom 1,000, so that if something is getting messed up, you can see. Another thing you want to check is that the column names or variable names have all been imported correctly. And then it's a good idea, some even advocate, and I concur, that sometimes you look at the top 5, you look at the bottom 5, everything looks good, but maybe the pattern of your data changes somewhere in the middle of the data set. So there are ways for you to ask and tell SAS, just give me the middle, Other ways is just to cut the data, which is subsets. So you chop maybe the top 1,000, you chop the middle 1,000, and then you chop the final 1,000 if it's a very huge data set. And I think this is a better comparison than the first screenshot I was telling you. So here you see the SAS data set on top, and you see the Excel data set at the bottom. And you can tell that everything is looking good based on the scenario we are looking at. But usually you have to do it for all the top variables. If it's, again, conducive, if the data set is small, it's very easy to do that. But when it's big, you have to Google and web search many ways of how to do something similar for a very huge file. I already went through user-defined libraries, and your unique U number always is specific to you. And then when you run a user-defined library, you want to check the log, and it will tell you it was successfully assigned as follows. There's a difference between temporary and permanent SAS data set. The temporary data set is what is stored in the folder called work. So you saw in the demos videos that work.import was an example of a data set. So it means the import was a temporary file in the work. So if you are working and you have not assigned any user-defined library, SAS assumes that you don't want this to stay in memory for a brand new session in the future. SAS will assume that you are just playing with the data sets temporarily, and then once you shut down SAS, all that work will go away. So it's very, very important if you are building up on the previous work in a new session, you have to create your user-defined library and then store all the data files inside that user-defined library. And so here's an example. We have the lib name, creating the library, user-defined library, WWC 2023. We are importing the data, purchase orders. We are also importing, so we are importing it first as a temporary file. And the way I know is that, look at the out equal to line. It is an identical program. We have two proc imports blocks, right? One on top, one here. But when we look at this, the out equal line of the first block is work.import. And that's how I know it's a temporary storage. But when you go to the second one, the second block, the WWC _ 2023 is now the folder. And that is essentially the difference between a temporary and a permanent file. If you don't specify the file type, this is not just the file location. This is actually the file location and the file itself. So that xls.x is pointing to the file itself. So if you do the third block, forcing SAS to produce an error prompt, you are not going to have anything. You are going to have an error. And I see a typo in the first block. So when you are doing it, don't just do .xls, do .xls, .xlsx, like the second one is the correct one. So earlier I used proc means to help us answer that question from a user who posted possibly his homework assignment online. But there are three popular procedures in SAS. You have the proc freq, which requests a frequency table that consists of the variable values, frequencies, cell percentages, and cumulative percentages. If you specify the wait statement, proc univariate includes, no, it's at the wrong place. It shouldn't include. Let's fix this. Because this is proc univariate. So proc freq requests a frequency table that consists of the variable values, frequency, cell percentages, and cumulative percentages. Proc univariate is used to explore the data. We've already talked about exploratory data analysis. And so proc univariate among proc freq and proc means are one of the ways you explore your data. And so you explore the data distributions of variables, summarize, visualize, analyze, and model the statistical distributions of numeric variables. He gives more descriptive statistics such as skewness, kurtosis, Q-plot, and so on. For more insight, you can Google all of these, but these are statistical terms. And so if you want to know more, that's a good way. You can Google and add Wikipedia or example and go to some sites and read more about it. It produces descriptive statistics on continuous variables, just like proc means, but many more of them, and also can produce some univariate plots. If you specify the weight statement, proc univariate includes the weighted count in the table and uses this value to compute the percentages. I suspect I should go back to its original place, but maybe it was a typo. It should have been proc freak, because I do remember using a weight statement before. And then proc means, as I demonstrated at the beginning to solve the Tableau question, provides data summarization tools to compute descriptive statistics for variables across all observations within groups of observations. It is used to find simple results like sum, mean, standard deviation, and to find extreme values. So these are resources directly from SAS. I'm going to drop in the chat for each of the procedures I've explained to you. So make sure to check them out. The one agreement among programmers is that sometimes the SAS documentation is like an encyclopedia. It gives you everything and every scenario that you can possibly think about. And sometimes that's just too overwhelming. And so that's why you've seen me Google and use an example, and we looked at that lessondata.com example where I copied the proc means syntax. And so if you Google, always add the keyword example. I learned it from a buddy at work, because if you don't add the keyword example, then it start getting into very encyclopedia-like documentation, but you just want an application, and the example keyword ensures you get that. And so here's how an output of proc freak looks like. If we were to run it on in SAS, right? You on the keyword category, or the column, I should say, category. Let me see if I can bring my SAS thing back up. I think it's probably have to re-sign into stuff. Right. And sometimes it tells you that it has auto-save if you weren't prepared, and it logged you out. So I'm just saying yes, yes, yes. Keep the most recent version. So this program here, we have the library created. We now gone through the importation of the orders tab in the Excel sheet, and now the people tab in the Excel sheet. And then you are making permanent copies after you bring in the orders file, which for all intents and purposes will be in the work import. This is how you sort a data set in SAS, proc sort. And let me go back to here to keep myself honest of what we are doing, so there's not much bouncing around. So I think what we wanted to look at was how you run a proc freak on this data set that you are bringing in. And I believe it's on there. I wonder which data set I use for this, because I'm not really showing it here well, but let me quickly. Okay, so I use this data set here. I use the orders and people data set. So remember, we've gone through bringing in the global superstore data set. Inside the global superstores, you will see two worksheets. One is about people and the other is about orders. I think the orders is the first tab and the people is the second tab. As we go through how to sort the data, and then we'll look at how to bring all the data together in a merge function. Once we do that, we are now ready to begin processing the data set. And so here we are running the proc frequency for the first time, right? And we can do this. The difference between this having the list and the missing in blue is the list and missing in blue makes it look nicer. But if you don't do it that way too, that also works. But I was always taught to use the list and missing by one of my bosses called Maria when I worked at a think tank called Mathematica. So let's do this. Okay, there are errors. Yeah, you always have to run this library when you come into a new session because SAS forgets about it. Okay, successfully done. And so now we can go to the frequency part and run this. And that's how we get the counts of the category. What is the type of order? We have furniture, office supplies, technology. And notice that it's giving you just the count. And then look at what it's also giving you. It's giving you the percent out of the total. That is giving you the percentage. Then it's giving you the cumulative frequency and also the cumulative percent. And these are all very useful stats by just running a little bit of SAS syntax code. Let's also run the second one to compare how it looks like if you drop the missing. And in this case, it looks the same because there are no missing variables. This is how you get a cross tabulation. If you are comparing two columns or two variables, like we want to see the category of the order versus the market, whether it's based in Africa or Europe or Asia Pacific and stuff like that. So let's run that proc frequency. And then you can see that it's broken it down by the type, but also by the markets: Africa, Asia, Pacific, Europe, LATAM, USCA. I think USCA is United States and Canada, and LATAM is Latin America. So, and you can confirm this on your own if these acronyms, I butchered it. So that's proc frequency for you. And I've shown you how we got that. Notice that it also gave you the totals at the bottom when you use the cross tabs, which is really a nice feature. Then this is an example of how you run a proc means. I already demonstrated at the top of the hour how you run a means, but essentially, if you are tracking along, when you run the data dictionary, the proc contents, and it gives you that list of table and the types of variables, all the categorical variables will show up as type CHAR, and all the numeric variables will show up as type NUM. When you are doing proc freq, you want to run the proc freq on the character variables. And then you want to run the proc means on the numeric or NUM variables. And by that, I mean this simply, I just mean simply, you come here and you probably do something like this. This is all I'm saying. You do a lot of copy and paste. when you are writing programs, because you don't want to. I was taught to write my codes as cap letters by my former professor, and so I've stuck to that. But this keyword, order equal to var num, is what ensures that the thing is nicely ordered. So something like this, you see the contents coming up. So what I'm saying is proc-freq is for all the chars, or CHAR, that's short for character, and proc means is for all the nums. That's all I'm saying. Notice that the position is now in a chronological order, 1 through to 24. But if I get rid of this by commenting it out like this, and I run this, the positions will be all over the place. So now you see that it jumps from 16 to 10 to 20 to 12 to 6, 7, and so forth. But if you do the order equal to var num, it orders everything. It's a really neat option to have. It's ordered it. So now that you know proc-freq and you know proc means, this is selecting the sales quantity and discounts because they were numeric, right? They are numeric when we look at them. Sales is num, quantity num, discounts num, and so you can tell there's even shipping costs and a bunch of other interesting variables. And so you now have the output if you run the code for proc means, and that will be a nice segue to getting into, what do you call it, the concept of macros. So earlier on, when I did, I ran the proc-freqs, notice that there were common values. Like, look at this proc-freq here, right? It looks exactly, actually, let's look at these two highlights here. The first proc-freq block here, you can tell that everything is exactly the same. The only thing that is changing in the program is category here, and then here is category asterisk market. Everything else is the same. And that is when the idea of macros becomes relevant. So imagine your boss or supervisor or client has asked you, I want to see all the various categories and counts by variable type in this data set. And you have a long list. You don't have the time to be copying. Sorry, I scrolled to the wrong. Yes, you don't have the time to do, oh, let me do, oh, I think I did something wrong. Okay, so you don't have the time to be doing, oh, I want category. Let me copy that, then paste. Then there's another category here. And the only thing you change here is market. Okay, and then let's say another categorical variable. By categorical, this means it's broken down into groups, and those are identified by the char or character CHAR. So let's say another categorical variable, ship mode. Okay, so now I want to get 3 frequencies of ship mode, category, and market. And so then I have to come here, copy and paste this one, and then do ship mode. If I think I didn't get it right. Okay, so ship mode has a space. And who can remember what you do when it's broken? You put a quote around it, and you put this value here, N, and it will highlight it in a different color. Other than that, the space will wreck you and it won't work. So it means that if I have 100 categorical variables to look at in a big data set, have to repeat it for 100 times. Nobody got time for that. I don't know if you saw that woman who said, ain't nobody got time for that. And so that's applicable here. Nobody has time to be copying and pasting the exact same program. That slightly changes. Okay, so if I were to do this, it will give me category, market, and ship mode. But even better, it's a good thing to introduce the concept of title statements, okay? You can do title 1, which is a statement that puts titles, and you can say frequency of category. And that way, when your output runs, the title will be at the top of it, and everything will not be too difficult to distinguish one from each other. And so you do this, and then the next one is what's ship mode. Right? So this is what you've successfully done. And then you can close the title. You can either do just title or you can put a number. Usually you put a number to track the titles. And the last statement, title 1, semicolon, is closing of the title. So let's run this. And then immediately you go to your log. Were there any errors? No error, no warning. Notes are purely information purposes, 99% of the time. And then now you have frequencies of category. You know, it makes it reading the outputs, you know what you are reading. And so we've done 3 frequencies, but what we did was copy the same block of code 3 times and slightly modified it. But it's okay if it's just a few times you are doing it. But if it's going to be like 100 times, then that's when the concept of SAS macros become very important and relevant. So the SAS macros, I know it looks very complicated, but hang with me, hang in there. You begin SAS macros, and this is an advanced concept, but I want you to be aware that SAS macros are how you avoid repetitions, endless repetitions in your programming. You tell SAS that I'm going to create a macro by saying % macro, and I'll put it in the chat, % macro. That's how you tell SAS, hey, I have a macro and I want you to recognize that I'm going to create a macro. % mend is how you tell SAS, I'm ending the macro that I told you to begin. In between the % macro and the % mend is where all the action takes place. In the macro line, the % macro line, you can give your macro a name. I think not can, you must give your macro a name. And so I'm giving this macro get frequency is the name of the macro. Then it's going to take this input, the set of input files. I'm calling it data file. I can call it anything, but it helps when you name it appropriately. And so it's data file and it's column, right? And this is the same block of code. Remember the proc frequency? It was the data, and we added the data file. We used the word tables, column, and the list missing. But we are introducing the % or ampersand, sorry, it's not %, the ampersand and column to be a receptacle to receive what in programming is called parsing. That is when you assign something to a function and it's able to process that function. You have successfully parsed whatever you submitted it to that programming. And then here is how you call your macro. You reference the name of the macro with a % in front of it. And then you finish the information. So here I'm finishing the information, get the orders and people data sets within the WWC 2023 library, give it to this macro get freak. And so the first argument will be mapped or attached to data file. And the second argument category will be attached to the column. So when the program reads proc freak, at this junction, or is it what? At this junction, the data file will be converted to this string because you are saying ampersand data file. And then the category would also be converted here, and it will be tables category. And so let's run this again, and you see that we are going to get the exact same. Oops. I think I missed something. Okay, that's fine. I definitely mixed something because I know that's because the colors here are looking weird. And so that's why I'm saying I think I missed something. But let's see if it will run. This is the macro we packaged. And it's not really saying much, but it's not producing any error. It's just saying you've created a macro get freak, that is get frequencies for short. It has 2 arguments, data file column. And at some point in the proc freak block, it's referencing the data file in the column. And then here is when you say, pass my 2 arguments, which are the specific instances, into this macro. And then you run it, and like magic, now you successfully run the first set of proc frequency for your category. Notice that if I want to now run the second argument for market, I don't need to now go and do another block. I can just pass it again. And then thankfully it wasn't broken. And now instead it's been changed for markets. And so we can do the ship mode as the third one that we got before. As the third one, I don't know why my colors are off all of a sudden. Must have done something. I wonder if this will work, but it might not work because there's a space between ship mode and I didn't test it before. But let's run this and see if it will work. Wonderful. So it works if you do it like that, if you surround it with quotes and stuff. So that was pretty deep as SAS gets, because you are now seeing how SAS macros work. Moving on, we have the proc univariate, which in earlier exploratory data analysis video, you notice that it says when you are doing univariate, meaning one variable, univariate means one variable, you can run the proc univariate procedure and it will give you a whole bunch of statistics. You have the count, which is n, mean or average standard deviation, skewness, uncorrected SSS, coefficient variation, sum weight, sum observation. So this gives you a whole lot of stuff and you are already in the world of statistics. The output had to be truncated and put on the side here, but these are all, it gives you quantiles, extreme observations or outliers. In statistics, whatever is extreme is called an outlier. And then there are some text, TEST, not text, tests. And it's giving you the t-test, student t-test, signed rank test, signed, and it's giving you some even p-values. So you are really now showing impressive stuff if you can convince employers or supervisors that, oh, I've used the proc univariate. That communicates that you are starting to grow in the use of your SAS. And then what we are now coming into is, I didn't touch briefly on the how to merge. Oftentimes you get this data set 1, data set 2, data set 3, but the information you want is found in the multiple files, and each file doesn't contain the whole sum information. And so there's a procedure called merge. And before you can use merge, you have to sort it with proc sort. It's just, you copy the syntax, you take in the input data set orders, you spit it out as sorted orders, and you sort by what variable. And I'm saying I want you to sort it by region. And so it sorts it by that region, and it sorts it by that region. If you do not state the out equal to sorted data set, what will happen is that the sorted data set will override your original file. So I always use the out equal to sorted data set and maintain this consistent convention of sorted in front of the former file. That way I have 2 files, right? But notice that if you don't put work dot in front of it, SAS still recognizes it as work dot, right? You will still find it in work. And then you saw the second data set, and then you merge. You can also SAS has an SQL integration that can also merge files, but that is an advanced concept. But for now, just know that when you want to merge, you have to go back to data step because you are managing the data. And so always that takes you back to data step. And so now that you've sorted both files and you are using the sorted files, you give it an index. This is how SAS remembers, is it in A or B? So quickly, if you've done joins or Venn diagram, you can quickly Google something like this and click on images, and you will see joins in SQL, which I think it was on Stack Overflow. I'm trying to make it a big, this is like a cheat sheet for you when you want to join data sets. So you just do something like this. Let me put the URL directly. It's a bit ugly, but that way you have that as a resource. And I'm going to also attach, I don't know if the file, yeah, the charts, I'm trying to bring you the graph itself. But yeah, so this is a whole wealth of information that I'm just downloading quickly so that it will make you aware of what's happening. So SQL joins, it's how you manage data to multiple data sets in different environments or sources. In SAS, the equivalent is the merge, the data step merge function. But as SAS realized that SQL is really popular, now SAS also has something called proc SQL, and it achieves the same purposes as an SQL. Remember, SQL is structured query language, and it's a standard by ANSI that when you are doing queries, you follow a certain format. And so Microsoft has built Transact SQL. Oracle has its own SQL, which is PL/SQL, and these are prevalent on the market. But SAS has its own thing as proc SQL. And so this is a case of red shaded. We are just looking at the first case here for lack of time. And it's telling you, for you to get A, when you are combining A with B, the way you get only A combined with parts of B that match what is in A is to use a left join. And so it's telling you select from table A, left join it to B on which key, whatever you are matching. But in SAS, because it's not Proc SQL, they do it in their own fashion. I'm trying to find the SAS file, but I'm not seeing it. Okay, it's here. So the same thing, we are bringing in the first set orders, which is A, bringing in the second set people, which is B, but we are saying we just want full A. And so that is the syntax, merging two files. So this is the scenario of the first circle, the two circles with A shaded in red. And then all the multiple scenarios on the chart, as you learn and work your way up, you'll be able to know how to combine it. As I was saying, SAS has an integration called Proc SQL. And it gives you more example, right? And so this is how you can do SQL in SAS and go after, if your background is in SQL, this is how you do SAS. But remember, I told you, if you Google and you don't add the example, you get that encyclopedia. But if you do an example, then you are going to get all kinds of libraries that are telling you exactly what to do. And so Proc SQL SAS example might be a better search word. Okay, our lesson data seems to be popping up a lot. And here they will give you the syntax. You copy the syntax. One distinguishing feature is Proc SQL ends with a quit, not a run statement. And so you can use Proc SQL. Let me put this to also achieve some of your data step purposes. I hope I've been clear so far. What we couldn't get to is graphic user interfaces in SAS. And quickly, SAS has these dimensions. Not tracking. Where is SAS? Okay, I don't know where my window ends. It might be Signal, but maybe we'll have another opportunity where we just focus on the interfaces, using the graphic user interfaces. So basically what you will do there is, let me start closing stuff so it's easier to find what I want. Maybe I closed it accidentally, but I wanted to show you where the SAS lesson is. I think I closed it without realizing, so let me quickly relaunch it. So all that we've been teaching is base SAS, the idea that you are laying the foundations of SAS programming. But SAS increasingly are realizing that there are people who also want to participate, but they don't know how to do the code. Knowing how to do the code is always advantageous because it gives you the capacity to master the data and cut it, whatever. And should something break in the automation or graphic user interface, you will be the one who will be called to fix it. But let's look at a few graphic user interfaces. So so far we've dealt under server files and folders. We have tasks and utilities, and that's where most of the graphics happen. And under you are going to find data, graph, map, statistics, linear, survival analysis. These are all power topics in statistics and econometrics, the statistics science of economics. And so you can say something like this, click on list table, do open, and then you are going to choose the data set you want. The thing is not really showing well, but you click on this icon and then you choose, okay, I need to run because I relaunched it again, it didn't work. Sorry about that. I needed to rerun this. Anytime you log out and you come back, that's the first thing you have to do. So now let's do the open again. And it's not, yes, it should be clean like this. Click on this icon and choose this in the library. Before it wasn't showing because we hadn't run the library. And then SAS will generate the code for you because it's a utility. Let's make this smaller so we can, yeah, that's what makes SAS sometimes a little cumbersome, but it's a lot of free stuff. And so it's generated the thing for you. And so you now know how to run programs. Control A, you click inside and then you click run. And then boom, you are getting some of the stuff we got. The dictionary, remember we had the dictionary? Interestingly, it's using proc data sets and not proc contents. But notice that it's telling it it's a content in here. And then you can go down the list and see characterized data. Let me look at my list here. I'm going to choose this data set and other dates. So you have to think through it for a while, and you right click, you open. If you open, it says code cannot be generated because it's waiting for you to definitely confirm the data sets, and you do so through the icons. And then it's saying, bring in a column. And I've already predetermined that I'd like to see other dates. And as soon as it has the minimum requirement number of variables, you see that the code will be generated. And boom, we now have the proc SQL showing. So SAS is not even using the merge, but the default is SQL. And again, it doesn't end in run, it ends in quit. That's one of the few departures of SAS. And so here, Control A, I run the program, and it's giving you my maximum. And so you can go through this list and do as much as possible. Maybe at a future time, I don't know when my schedule will allow, we can just focus on graphic user interface functionalities. And then there's graphs. If you want to do graphs, you pull it down here. And remember, we read through the various types of visualizations, right? And so you can describe missing data under the task data. You can also describe, you can also do a filter. But if you want to do graphs, you can choose these and then so let's do orders and people and region, for instance. So I'm going to go here, bar charts, right click, open. Orders is already predetermined, but let me be sure it's determined already because it's now remembering what we chose last time. And then you have to scroll because sometimes it's hidden. And then you are going to choose, let me be careful. We are going to choose region to see an instantiation of a graph. So region is here. I double click it. And what else? It was thinking. And so SAS is now using a procedure called sgplot And let's see what it does. I click here, Control A, I run it. Now you are really having fun and you are on a roll, because this is it. If you need more room, you can click on that and it will give you more room. Or you can go to, even SAS is doing a good job where you can download some of these things and share it with your team. So it has download results as a HTML file. Some of these are grayed out. I'm not sure why it's not showing the PDF and the RTF, which is like a Word document, rich text format. Download, print results. See, open in a new browser, email results. So let's see something like this. So let's put this in the chat. You might not be able to access it, but hey, that's how you view it in its own window. If you were to download it instead, then you are going to have something like this, bar chart results. And then it's showing as HTML, just like if you had popped it up in in a separate window. If you want to email it, you see it's doing this for you. I'm going to say attach code, summary, log, PDF is blocked out for some reason. I need to look into that. And I'm going to email it to my Women Who Code email. I'm going to CC my coders who travel. And I'm going to say bar chart results and say maybe, dear Afia, check these bar chart results out. Love, we all need love, Afia, and send it. And I'll be curious to know how it shows on the other side. Let me quickly check if it is appearing or not. But we've seen a little bit of how SAS quickly produces. Yes, it's actually here, which is magic. So now you see bar charts results. This is how you email it to your team member. Says no preview available. Let's put it in Women Who Code Accra. Because you don't have SAS on your desktop, you have to choose a notepad just to see it. And this is your SAS code that has been shipped directly to your email. Obviously, there's bar charts HTML. For some reason, maybe being downloaded from the email is not really helping. But if you download it directly, you can see the same charts directly on your desktop. Then there's the log, what SAS affirmed about your procedures, and then there's the chat. So your homework basically going forward as this introductory class ends is, how do I do these charts I learned about? I tried to cut it differently, okay? And I did something with a chloropleth math and got something like this, even for the map. SAS is great, but SAS, traditional SAS, had its challenges in being like a very powerful machine and complex. And that's when Tableau and other tools came on the scene. They do these charts even quicker. Back in my graduate school days, there was no, GUI functionality for in base SAS like you have it now. But I'll say explore it, explore the different charts we read about, and see how you can leverage SAS to produce them. Once again, resources are Learning SAS by Example, Little SAS book. That's how I learned it. I built this lecture based on my experience and time in grad school, but these were the books that kickstarted my SAS career. I also want you to know there is now SAS in the cloud called SAS Via. Make sure you learn about it because everybody is talking about it. SAS is trying to compete with Tableau and other tools that go quicker. And so these things are actually working well. Sorry, the links didn't pop up nicely. Let me do it individually. And then we would have come to a good stopping point for tonight's lecture. Let me share the links. And this is the future of SAS. So you just got a tip of the iceberg. Obviously, the real action begins, hopefully for you. You can follow me and send some questions as you go through your journey. SAS Cloud, you can find it here directly. I've already shown you. And then there was an appendix. Let me quickly look at it. Yes, there's a place called Kaggle. You can get data sets to plan your career and portfolio in SAS. And then, as usual, this is for 5 minutes time for question and answer. Thank you so much for hanging out with me. I know this was a lot, but I hope you found a lot of value in these 2 introductory lectures. You can reach me out at afia@womenwhocode.com. Always CC afia.o.forfie@coderswhotravel.com as well. You can follow me on LinkedIn here. And also, when you follow me, tag Women Who Code wherever your channel is. And also tag me. So not just Women Who Code, but tag Owusu-Forfie on Twitter. You already have the LinkedIn. And then tag Women Who Code Accra, because we are doing mighty things and making sure the next generation of African women and some good men, I know there are men here, and can all pick up programming. So quick questions, 5 minutes, and then we'll close out.